Hi, and thank you for tuning in to PSPN, America's favorite physics sports network. I'm Mike, and tonight we've got a lot of sports and physics for you. The first thing we're going to look at tonight is basketball, and I'm going to let Mr. McGurliger tell you all about it.
Mr. McGurliger here. Let's take a look at this basketball shot. Nice, real nice. What we see here are kinematic equations. When it comes to basketball, these equations can tell us everything we need to know about what is happening to this ball. For example, how fast it's going, how far or how high it goes, how much the ball weighs, how fast it accelerates, or how long the ball is in the air. Let's take a look at the data I've collected from this particular shot. Now, by looking at these variables, we can figure out the exact conditions you'd want for the perfect shot. Let's use these variables to figure out the acceleration of the ball. Using the equation velocity equals velocity initial plus acceleration times time, we can rearrange it to solve for acceleration. Using the variables we have and simple algebra, we come to the conclusion that the acceleration of the ball is 22.8 meters per second.
Wow, what a shot. Well, thank the Lord for kinematics. For our next segment, we're going to talk about baseball.
Great hit. He must have had a lot of momentum. Now, we hear that all the time, but what does it really mean? What is momentum? Momentum is defined as the mass of an object times its velocity. Impulse is defined as the change in momentum. This baseball definitely goes through a serious change in momentum. Looking at this graph, you can see the sudden change in velocity. Using the data I've collected, we can find the initial momentum and the final momentum. Now, to find the change of momentum, we are easily able to subtract and find the impulse.
Thank you, Mr. McGurliger. Now tonight, we are also going to take a look at the physics involved in soccer, America's favorite sport.
When it comes to soccer, you need to have a lot of force to get a good shot. But what does it take to have good force? Newton's second law of motion states that force equals mass times acceleration. In order to figure out the force of this kick, we first need to figure out our acceleration. So let's bring back our kinematics from basketball. Looking at this data table, we are able to get our velocity and our time in order to solve for acceleration. Our acceleration is going to equal 35.47 meters per second. When we multiply our mass times our acceleration, our force ends up being 15.96 newtons.
To wrap up our PSPN programming for tonight, we're going to take a look at football, the actual most loved sport by Americans. Tell us, Mr. McGurliger, what kind of physics do we find in football?
Well, Mike, we've got it all. Kinematics with the throwing, laws of motion with the kicks, power with the hits, but also collisions. One thing that you must know about collisions is that in collisions, momentum is always conserved. This is the equation for the conservation of momentum. This equation shows us how when these two very professional athletes collide, the momentum of the first athlete will equal his momentum plus the momentum of the second athlete in the end.
Thank you for tuning in to our PSPN programming tonight. Be sure to join us next week for our duck races. Force buoyant. It's important.